This is the first lecture of electrochemistry. First of all, we are going to see what is electrochemistry. What is electrochemistry? So first of all, I am going to define electrochemistry, then I will explain it. It is the branch of, write with me, it is the branch of physical chemistry which deals with the study of interconversion of chemical energy and electrical energy So basically what we study in electrochemistry is that interconversion of chemical energy and electrical energy, how we are going to convert chemical energy into electrical energy and electrical energy into chemical energy. So this is our first lecture of electrochemistry, and we need to study interconversion, that means chemical energy into electrical energy and electrical energy into chemical energy. So first of all, we are going to start electrochemical cell. Yes, Samia. So basically, I just defined the chapter's name. Basically, in electrochemistry, we study interconversion of chemical energy and electrical energy. How we obtain electrical energy from chemical energy and how we obtain chemical energy from electrical energy. So after this, we have a topic that is electrochemical cell. Electrochemical cell. There are two types of cell. There are two types of electrochemical cell. The first one is galvanic cell or voltaic cell. The first one is basically, here is galvanic cell, or you can say voltaic cell, and the another is electrolytic cell, and the another is electrolytic cell. So what is the difference between this electrolytic cell or galvanic cell? So basically in galvanic or voltaic cell, chemical energy converted into electrical energy. We use chemical energy to produce electrical energy. In the same way, I can write electrolytic cell. What is electrolytic cell? So basically, we use electrolytic cell to convert electrical energy into chemical energy. So this is very easy to understand. There are two types of cell, electrochemical cell. One which is used to convert chemical energy into electrical energy is called galvanic or voltaic cell, and its example is, we can take Daniell cell, and one which is used to convert electrical energy into chemical energy. Also, it is important to note that in this galvanic or voltaic cell, a spontaneous redox reaction takes place. A spontaneous redox reaction. In both the cases, redox reaction, there are redox reaction. There will be redox reaction in both the cell. There will be redox reaction, but in galvanic or voltaic cell, there will be a spontaneous redox reaction. That means it will occur on its own. But in electrolytic cell, it is non-spontaneous. Redox reaction. That means it will require external agent to carry this reaction or to carry this cell. Okay. So please write it. I'm going to take water. So again, what is electrochemistry? So basically in electrochemistry, we study the transformation of chemical energy into electrical energy and electrical energy into chemical energy. That is electrochemistry. And there is two types of electrochemical cell, that is galvanic cell or electrolytic cell. In galvanic cell, there will be a spontaneous redox reaction which will be used to convert chemical energy into electrical energy. But in electrolytic cell, electrical energy will be converted into chemical energy with the help of a non-spontaneous redox reaction. Or you can say in this when we convert electrical energy into chemical energy, there will be non-spontaneous redox reaction. So please write it and let me know.
Done, sir.
Very good. Rim and Madiha.
Done, sir.
I'm still writing survey.
Okay, okay, take it. And in the last class, I took a test, right?
Yes, sir.
Okay. So today
Done,
is
sir.
Wednesday. Thank you. Monday, it's Monday. Okay. Now, going to introduce a new term that you already know from your childhood, that is conductor. Anyone, what is conductor? Conductor, substances which allow current to flow through them. Allow current to flow through them are called conductors. So basically, a substance in which current can flow is called conductors. And conductors here are of two types. I'm going to take example of conductors. Conductors can be metals, aqueous solution of acid, bases, salt, acids, bases, salts, etc. Now, these conductors are of two types. Conductor are of two types. The one is metallic conductor, also known as electronic conductor, and the other is electrolytic conductor, also known as ionic conductors. So I'm going to differentiate between these conductors. So first of all, you are going to write this and let me know. Then I'm going to make a box, then we'll differentiate between them.
Done, sir.
Thank
Done,
you.
sir.
Okay. Rim,
Done, sir.
is there any test in your school that happened before the starting of this class, of our class? Is there any test? Unit test? Samia, Rim, and Madiha?
No, sir.
No test.
Sir, my school is now closed for vacations.
Okay, I was just asking, is there if there any test that happened, unit test, just let me know because I need that test paper. Okay.
Yes, sir. It happened for me before the closing of school.
Okay. So Madhya,
Sir, of school?
Yeah, school.
Yes, sir. Even for me, it happened.
Okay, so please, can you send both of you? Are you in the same school?
I don't think so, sir.
Okay, so please, both of you send the question paper in the group. Madia, you are also added now.
Yes, sir. Okay, I'll send after the class.
Okay, tonight please send it. Okay, so there are two types of conductor. That is metallic conductor, also known as electronic conductor, also known as electronic conductors. And the another one is electrolytic conductor, and it is also known as ionic conductor. So can anyone tell me what is the difference between this electrolytic conductor and metallic conductor? Anyone? What is the difference between metallic conductor and electrolytic conductor? So the first difference is that since both are conductor, that means current will flow from both of them. But the most important difference between them is in metallic conductor, the charge carriers are electrons, and in electrolytic conductor or ionic conductor, the charge carriers are ions. Are you getting my point? In metal, the mm, um, the conduction takes place with the help of electron by flowing of electron with the movement of electron. But in electrolytic conductor, the current flow with the help of ions. So I'm going to just write it. Charge carriers are free electrons, free electrons. And here we can write charge carriers are free ions, free ions. Second point we can differentiate with flow of electricity takes place without any chemical change. There will be no chemical change. Without any chemical change. But here, flow of electricity takes place by chemical changes. By chemical changes at electrons. At electrons. You will see ahead that in electrolytic cell, there will be change in chemical at electrons. The third point we can write about it. Resistance is due to vibration of kernels. Do you know what is kernel? Anyone? Kernels is cloud of electrons, group of electrons. And here resistance is due to Am I audible to all of you?
Yes, sir.
Yes, sir.
Okay. No transfer of matter takes place transfer of matter takes place. Transfer of matter takes place in the form of ions. Next point, which is very important, Faraday's law of electrolysis are not followed in the fifth point. Faraday's law of electrolysis are followed. Please write it and read at least once and let me know if you have any doubt in any of the term, then I will explain. If you won't have any doubt in any of the term, then I will ask the question. By the way, it's very easy.
Sir, can you explain the third point of ionic conductor?
Resistance is due to, first of all, I'm going to ask the question, what is resistance? Rim, what is resistance? Any one of you? Rim, you can speak up. You are not audible now. Samia, Madiha,
The ability to resist charge.
charge? No. So basically, resistance is the property of any conductor which resists the flow of current. That is resistance. It doesn't resist charge, but flow of charge it resists. Are you getting my point, Rim?
Yes, sir.
So see here, the flow of the current is due to the movement of ions, and if there will be attraction between ions, will it be easily flow? Will it easily flow or not? If there will be attraction between two ions, and one of the ions wants to flow, and another ion is attracting towards itself, it's tough to flow. It will reduce its speed, Rim.
Yes, sir.
So that's why resistance that means flow of current, the property which resists the flow of charge is due to interionic attraction. The first point is interionic attraction. See, just suppose we have, are you done with all this?
Yes, sir.
Samia and Madiha?
No, sir.
Okay, just please write it and then I'll explain in another slide. Please wait.
Done, sir.
Madhya, are you done with this?
Yes, sir, I'm done.
Okay. So see, just suppose there is electrolytic cell, that means it will have solution, and just suppose there is Na plus and Cl minus, and just suppose this positive charge wants to migrate from here, but this chlorine will attract Na plus towards itself, so it will reduce its speed. That's why resistance is due to the interionic attraction between the ions. And the second point is viscosity of medium. Does anyone know about viscosity? So basically in class 11th, you have studied in gaseous state, liquid, that is viscosity. Viscosity is basically friction. Friction in liquid or fluid is called viscosity. So if ions is traveling and the medium in which it is traveling or in which it is flowing is the medium, if the medium will have high viscosity, so the flow of ions will be lower, or you can say the flow of ions, the speed of ions will be slow. That's why it will also cause the rise of resistance due to the viscosity of medium. Is that clear?
Yes, sir.
Any other point that you haven't understand, any of you? So basically the first point, charge carriers is free electrons and charge carriers are free ions. Flow of electricity takes place, no chemical change, but flow of electricity takes place. There will be chemical change at electrodes. You will see when we will study about Danielson. Resistance is due to vibration of kernels. That means the electron will vibrate. It will be like SHM. That's why its resistance rises. And here resistance is due to the interionic attraction and viscosity medium. No transfer of matter takes place, only electron travels. But here transfer of matter takes place in the form of ions. And then the fifth point, which is very important, and we will learn at the end of this chapter, what is Faraday's law. In metallic conductor, Faraday's laws are not followed, but in electrolytic, Faraday's law of electrolysis are followed in electrolytic conductor. Electrolytic conductor. Is that clear, everyone?
Yes, sir.
Yes, sir.
See, we have two types of electrolytes. Electrolytic conductor, you can say, or we have two types of electrolyte. The first one is weak electrolyte, and the second one is a strong electrolyte, and the second one is a strong electrolyte. So basically, what is weak electrolyte and what is a strong electrolyte? So in this electrolyte, weak electrolyte, partial dissociation takes place. Partial dissociation takes place. And in a strong electrolyte, complete dissociation takes place. Complete dissociation takes place. Just like you can take an example of HCl, and HCl will be converted into 100% H plus Cl minus. Alpha is equal to 1 or alpha is equal to 100%. In percent, it will be 100% almost. But in partial weak electrolyte, it is 0 to 5% max, 0 to 5%. Up to 5% it will, or you can say 10% partial dissociation. According to the question, it will be 40%, 50%. So basically partial dissociation takes place, like if you are going to dissociate CH3COOH, that is ethanoic acid, it won't be 100% dissociated, it will be partially dissociated. That's why it is weak electrolyte and it is a strong electrolyte. Is that clear?
Sir, what is alpha here?
Alpha is basically you can call it dissociation. Wait a minute. Degree of dissociation. This is degree of dissociation. Alpha is degree of dissociation. Haven't you heard in class 11 equilibrium?
Yes, sir.
Just take an example. Just suppose we have given a question. That this is just suppose CH3 COOH. You just take CH3 COOH, and this is CH3 COO minus, and this is H plus. Initially, it has 2 mole, and it has given that alpha is 5%. That means alpha is dissociating only 5%. First of all, you will see whether the the equation is balanced or not. What do you think? Is this equation CH3 COOH dissociating into ions is balanced or not?
No.
Is it balanced or not? Did you just say no? Just look at the equation. How you see whether a reaction is balanced or not? First of all, you are going to check the number of different atoms on the left hand side and the number of different atoms on the right hand side, whether they are equal or not. First of all, go for atoms and then go for charge. On the left hand side, there is no charge. On the right hand side, check the total charge. Here it is negative and here it is positive. +1, -1. What will be the total charge on the right hand side? What will be the total charge on the right hand side? Rim, Samia, Madiha. Am I audible to all of
Is it
you?
equal to the left hand side?
What you just said, I couldn't hear you. Sorry.
It's equal to the left hand side, the charge.
Okay. Yeah, you can say that on the left hand side, neutral, because there is no charge. On the right hand side, you can see there is negative, -1 and +1. Total charge -1 +1 will be 0, and the atoms are also balanced. Total number of carbon on the left 2, total number of the carbon on the right 2, total number of hydrogen on the left 4, total number of hydrogen it is 3 + 1 4, total number of oxygen on the right hand side 2, total number of oxygen on the right hand side 2. So what I want to tell you is about alpha, degree of dissociation. Just suppose in the question it is given that 2 mole and 5% alpha. That means only 5% will be dissociated. So 5% of 2, what it will be? It will be 0.1. That means in 2 moles, it will be only 0.1 dissociated. So 0.1 here it will be formed and 0.1 here. Got it? Rim, Samia?
Yes, sir.
Yes, sir.
Okay. Can I change the slide or are you writing?
Sir, writing.
Okay, take your time.
Done, sir.
Very good. Everyone done with this?
No, sir, I'm still writing.
Rim?
Done, sir.
Okay. Okay. Madhya, just let me know whenever you are done with this. So in electrochemistry part, there is some part of current electricity too. Electrolytic conductance, we will talk about it post of this test.
Done, sir.
Okay, thank you. Now write the topic, that is electrolytic conductance. Electrolytic conductance. So first of all, in electrolytic conductance, we have a resistance that we just discussed about. Resistance is denoted by R, and I'm going to define and see what is the unit of it. So the property of conductor to resist the flow of charge, to resist the flow of charge is called resistance. Can anyone tell me the unit of resistance?
Ohms.
Ohm.
Yeah, unit of resistance is ohm, and we denote it as this. Also, we know that from Ohm's law, V is equal to IR. So R will be equal to V upon I. R will be equal to V upon I. So one by one, there will be terms related to conductance we are going to define. So after this, we have just focus on this conductance, which is denoted by G. Conductance is denoted by G. And how we are going to define it? The conductance of a conductor, the conductance of a conductor is equal to reciprocal of resistance, is equal to reciprocal of resistance. So please write it and let me know when you are done with this. So what is conductance? Conductance is reciprocal of resistance, and by this definition, we are going to have a mathematical equation that we can call it a formula, which is very important. There will be Viva on Wednesday for half an hour max. Okay.
Okay, sir.
Sir, for which chapter?
I think we will go for solution. I just took subjective test, and then we on Wednesday we will have Viva, and on coming Wednesday we will have next to next we will have objective test, and then in a month we will have 4 tests total. Let me know when you are done with this.
Done, sir.
Samia and Madhya.
Done, sir.
Done, sir.
Now see, from this definition, you can easily write a equation. An equation G will be equal to 1 by R. Conductance is equal to 1 upon resistance. Now, unit of G, that means conductance, will be, can I write per ohm? Per ohm, because 1 upon ohm, that is per ohm. Yes or no? Rim,
Yes, sir.
Samia, Madhya. Now,
Yes, sir.
this per ohm is also known as MHO. It is just opposite of ohm. Okay, and this is also known as Siemens. This is also known as Siemens, and we denote it by S. So what is the difference? There is no difference. Basically, the unit is per ohm, and per ohm is also known as mho, and per ohm is also known as Siemens. That is denoted by S. It's all units of conductance. Is that clear?
Yes, sir.
Very good. Just write it and write another term, that is a specific resistance, or you can directly call it resistivity. Resistivity, and we denote it by rho. Denote it by, and we denote it by rho. So how do we define resistivity? So basically, according to the concept, resistance is directly proportional to the length of the conductor. Resistance is inversely proportional to the area of the cross section of the conductor. If the length of the wire will be increased, resistance will also be increased. And if the area of the cross section of wire will increase, resistance will decrease. They are inversely proportional to each other. So combining these two equations, we will get resistance directly proportional to L and inversely proportional to A. And to remove this proportionality sign, we will have a constant, that is rho, and also known as resistivity and a specific resistance. Are you getting my point? You have studied about this in class 10th also, and you will study about it in class 12th also, current electricity. Yes or no?
Yes, sir.
Yes, sir.
Okay, please write it and then we will talk about it.
Done, sir.
Done, everyone? Maria and Dream.
Done, sir.
Done, sir.
Very good. Now see, I'm going to obtain the formula for resistivity from this formula. So we have basically R is equal to rho L by A, and we can easily calculate rho will be equal to R into A upon L. Can I write it like this? And we can go for unit of resistivity. Unit of resistivity. Now you can see unit of resistivity, that will be unit of resistance, that will be ohm. Unit of area, that will be meter square, and unit of length of the conductor, that is meter. So basically ohm meter, or generally unit of resistivity in this chapter, we use centimeter instead of meter. Ohm centimeter, or you can also write ohm centimeter.
Done, sir.
Thank you. Everyone done with
Done,
this?
sir.
Done, sir.
Very good. Wait a minute. Wait a minute. Wait a minute. Please let me see the question on this. Okay, let's go. Now this next term, this was basically uh, B, C, and then D. A specific conductance, specific conductance, and we also call it conductivity, conductivity, and we denote it by kappa. This small k look like a small k is kappa. We call it kappa. So what is basically a specific conductivity and a specific conductance? So basically it is defined as a reciprocal of a specific resistance, reciprocal of a specific resistance. So kappa can be written as kappa will be equal to, wait a minute, kappa is equal to 1 upon rho. Can I write it? 1 upon rho. And you also know that R will be equal to rho L by A. And rho will be equal to A into R upon L, or you can write R A upon L, whatever you want. And we need to calculate kappa. Kappa, how we are going to just take inverse of this. Inverse. If you are going to inverse this, that means 1 upon rho, and here it will be 1 upon R into L by A. Can I write it? Inverse, that means denominator in numerator, numerator in denominator. And this you can see 1 by rho can be called 1 by rho can be called kappa, and kappa is equal to 1 by R into L by A. Can I write it? Yes or no? Please tell
Yes.
me. Now, you also know that kappa 1 by R is basically conductance, resistance, conductance. What is conductance? Reciprocal of resistance, reciprocal of resistance. And this L by A is G star, and G star is basically cell constant. I will define it soon. Cell constant. See, you can also solve this equation to find the value of kappa in your own way. What I just did is I know that kappa is equal to 1 by rho, so that's why I just inversed. I just took inverse of this, and 1 by rho can be equal to kappa 1 by R, L by A, and L by A, length of conductor per unit area of cross section of conductor, is called cell constant and is denoted by G star. That's why I wrote it. Please write it, and then we will talk about the units and all other things.
Done, sir.
Done, everyone.
Answer.
Done, sir.
Very good. Now see, can I write it? Kappa is equal to, I just wrote, kappa is equal to G into G star. What does this kappa means? Kappa means a specific conductance. A specific conductance will be equal to conductance into cell constant, into cell constant. Also, it is important to note that from here, unit of kappa, that means conductivity or a specific conductance. You can see 1 by R, that means 1 by ohm. That means I can write per ohm, and you can see this is meter or centimeter, this is centimeter square, so it will be per centimeter. So we can also write mho per centimeter, or we can also write per ohm, or mho is also known as Siemens per centimeter. So the unit of kappa is per ohm per centimeter, mho per centimeter, or Siemens per centimeter. Okay. Let me know when you are done with this.
Done, sir.
Very good, Madhya.
Done, sir.
Rim and Samya, I'm waiting for you. Samya, Samya, are you done with this?
Done.
Now see, there will be another term, that is cell constant. And cell constant is very easy. What is cell constant? Cell constant is denoted by G star. And basically, G star is equal to length of the conductor upon area of cross section of conductor. And what will be its unit? Unit is, you can see, centimeter upon centimeter square per centimeter. Is its unit? Please write it. And after that, you are going to take another term, that is molar conductivity, or we can call it molar conductance. Molar conductivity and molar conductance, and is denoted by lambda m or mu, is denoted by this. So after writing this topic, let me know. First of all, I'm going to define it, then I'll explain it. It will be very easy. Let me look at the question of
Done, sir.
oh, wait a minute. Let's
Done.
look at Madhya. Oh, very good.
Done, sir.
Very good. Thank you. Okay, got it. Now see, I'm going to define it. So first of all, write the definition with me. Molar conductivity or molar conductance is defined as, as the conductance of all the ions produced, by 1 mole of electrolyte, present in the given volume of solution, So basically, there are two terms, molar conductivity and equivalent conductivity. Whenever we talk about molar conductivity, that means conductance due to 1 mole of electrolyte in the given volume of solution. Conductance due to 1 mole, only 1 mole. Conductance due to only 1 mole of electrolyte present in the given solution, that present in the given volume of solution, that is called molar conductivity. Now see, there will be an equation, and we are going to form an equation formula. Molar conductivity will be equal to specific conductance into volume. If you are going to increase the volume, conductance increases. Why conductance increases? If you are going to increase the volume, the distance between ions will be larger and there will be lesser force of attraction, so that they will easily, they can move faster than the earlier. That's why. So I'm going to write V is equal to basically volume of solution containing 1 mole of electrolyte, and now if concentration of solution is m mole per liter, that means molar conductivity will be equal to kappa into 1000 upon molarity. Kappa into 1000 upon molarity, m mole per liter. So please write it, and then I will again explain it. It's very easy. Let me know when you are done with this.
Sir, are we not doing E0 cells?
No, we are doing electrolytic conductance. After this, I will from NCERT. It will be different for topics, but every topics will be covered. Don't worry about that. Okay, Samia. First of all, after this, we are going for Corlot's law in the next lecture. After completing Corlot's law, then we go for potential, then Nernst equation, like this, and then electrolysis, then Faraday's law, and then batteries. So don't worry about the topic. Every topics will be covered. Everyone done with this?
Yes, sir.
Yes, sir.
Madiha and Rim. Rim, there is no Rim. Let me check. Okay. So basically, what is molar conductivity? Conductance due to 1 mole of electrolyte in the given volume of solution is called conductivity. So molar conductivity is equal to conductivity into volume. Now see, if the volume of solution containing 1 mole electrolyte, and if concentration of solution is m mole per liter, that means lambda m, molarity will be kappa into 1000 upon m. Now it's important to note its unit. So the unit will be, as you know that the kappa will be equal to what? Per ohm per centimeter. So its unit will be equal to per ohm centimeter square per mole, or you can also write Siemens centimeter square per mole. This is the unit of molar conductivity. So write the unit of molar conductivity, and then we will go for equivalent conductivity or equivalent conductance. Equivalent conductance. We denote it by lambda EQ. That is EQ or lambda EQ. Please let me know when you are done with this.
So that's mole, right? Or mole? In the
Per
unit.
mole, yes, it's per mole. Per mole. Okay. I'm going to write it again. It's per mole. It's per mole. Let me know when you are done with this.
Done, sir.
Done, sir.
Okay. So basically in the previous formula or term, you saw that is due to 1 mole electrolyte. And here we are talking about equivalent. That means we will talk about the conductance due to 1 gram equivalent in the given volume of solution is called equivalent conductivity. In the same way that we defined for the molar conductivity. In molar conductivity, we talked about 1 mole electrolyte, and here we are going to talk about 1 gram equivalent. So I'm going to define it. It is defined as conductance of all the ions produced by 1 gram equivalent of the electrolyte in the given volume of solution. In the given volume of solution. That is called equivalent conductivity. In the same way, lambda EQ will be equal to kappa into volume. If we are going to increase the volume, then equivalent conductivity increases. And in the same way, if V is equal to volume of solution containing 1 mole, not 1 mole, since it is equivalent conductivity, we are talking about equivalent conductivity. So 1 gram equivalent of electrolyte. And just suppose if concentration of solution is n gram equivalent per liter, n gram equivalent per liter, then we will have a formula same as molar conductivity. That is, equivalent conductivity will be equal to kappa into 1000 upon n.
Am I audible?
Yes, sir. Sir, can you scroll up?
Yeah. Is it good now? Oh, sorry. Let me know when you are finished.
Done, sir.
Are you done with this?
Yes, sir.
Okay. So here we got two formulas for equivalent conductivity and molar conductivity as well. Right? Wait a minute. Now, the relation between write a topic. The relation between equivalent conductivity and molar conductivity. So see, molar conductivity is equal to kappa into 1000 upon m, and equivalent conductivity is equal to kappa into 1000 upon n. Also, we know that normality is equal to valence factor, or n factor you can call it, valence factor into molarity. Valence factor into molarity. So if you are going to put the value, so you will get a formula. Equivalent conductivity will be equal to molar conductivity upon valence factor, VF. Or you can also write molar conductivity will be equal to equivalent conductivity into valence factor. So this is very easy. You just need to put the value of n here and you will get your answer. Okay, everyone.
Yes, sir.
Let me know when you are done with this.
Sir, how will you calculate the valence factor?
Valence factor is basically the change in number of electrons, transfer of electrons, you can call it, transfer of electrons. Okay, or you can call it change in oxidation state or reduction, change in oxidation state. Okay,
Okay, sir.
so just like if you have H2 plus O2, it's gonna be H2O, and if you are going to find the oxidation state 0, 0, plus 1 and minus 2. So the valence factor for this, you can see 0 to 1, the change will be 1. And for oxygen, it will be 0 to minus 2, the change will be 2. Are you getting my point?
Yes, sir.
Okay, but yeah, here you can see there are 2 hydrogen. So the total change will be 2. I am talking about the plus 1 for 1. So for 2, it will be 2 or not.
Yes,
What
sir.
I am trying to say is that oxidation state of H2 is 0. Oxidation state of hydrogen is plus 1. But this is for 1 hydrogen, no? So for 1
Yes,
hydrogen,
sir.
there will be change of 1. So for 2 hydrogen, there will be change for 2. So valence factor is 2. And valence factor is also, I have explained in solution chapter when we were studying normality. Do you remember acid, base, and salt? Madiha?
Yes, sir, I do.
Okay. Let me know if you are done with this. Then we will have a question.
Done, sir.
Done, Madhya, you
Done,
also
sir.
done?
Yes, sir.
Thank you everyone. Now let's start a question. Write a question. The resistance of a one normality solution of salt is 50 ohm. Calculate the equivalent conductance. Calculate the equivalent conductance of the solution if the two platinum electrons in solution are 2.1 centimeter apart and each having an area of 4.2 centimeters. Please do this question.
Sir, can you explain?
Okay. Okay, I'm going to explain. The resistance of a one normality solution of salt is 50 ohm. Calculate equivalent conductance. Equivalent conductance has a formula that is kappa into 1000 upon n. Now you can concentrate on the formula. Normality is given and we need to calculate this, and kappa is not given, that is a specific conductance. So basically we need to calculate kappa first, and kappa has a formula that is 1 by rho is equal to 1 by r. Since rho is not given, so we will use the formula of resistance upon into L by A. Now just see, kappa will be solved. 1 by r has a value 50, L has a value 2.1, and area has a value 4.2. Now this will be cancelled by 2 times. So basically kappa will be equal to 1 by 100. Okay, and now you can easily put this value in this. 1 by 100 can be written as 10 raised to the power minus 2. 10 raised to the power minus 2 into 1000 can be written as 10 raised to the power 3 upon n has a value 1 normality. So it is solved. Now 10 raised to the power 3, 10 raised to the power minus 2 plus 3, that will be equal to 10. So equivalent conductivity will have a value. Siemens equivalent. Is this clear?
Yes, sir.
Please write it.
Done, sir.
Very good. Now I'm going to give you another question. That is, which of the following have maximum molar conductivity? A is basically 0.08 m solution, and its specific conductivity is 2 into 10 raised to the power minus 2 per ohm per centimeter, and B is 0.1 m solution, and its resistivity is 50 ohm. Please do this question. 50 ohm centimeter. Can you do it?
No, sir.
Okay, listen. We need to compare molar conductivity. So for A, molar conductivity, the formula will be kappa into 1000 upon m. Now see, kappa has a value 2 into 10 raised to the power minus 2 into 10,000, that means 10 raised to the power 3 upon molarity has a value 0.08. Now you can also find this 3 into this will be solved, and here it will be 10, and it can also be solved into 8 into 10 raised to the power minus 2. Can I write it? Tell me.
Yes.
Now you can see this will be cancelled by 4 times and 1 by 4, and if it goes in numerator, it will be in positive, and here it will be 10 raised to the power 3. And again, if you are going to solve it, 0.25 into 10 raised to the power 3, which means 250 Siemens centimeter square per mole. Can I write it? It's normal calculation.
Yes, sir.
Now see, again I'm going to apply the formula kappa. Kappa for this, since see there is resistivity in this. Resistivity is 50 ohm centimeter. Now if you are going for kappa, it will be 1 by 50. 1 by 50, yes or no?
Yes.
Kappa and resistivity has a relation. So it will be 1 by 50 and here it will be 1000. And what is the value of molarity here? It is 0.1. Now this is 1000. Just cancel the 0, and you can see it will be 100. And if you are going to cancel it, it will be cancelled by 20 times. So it is 20 upon 0.1. If you are going to remove this decimal, 0 will be here, and the answer will be 200 centimeter Siemens centimeter square per mole. So which one has more or larger molar conductivity? A?
The first
Yes
one.
or no? Madhya, Samia?
Yes.
Okay. So please write it. This is it for today, and we are going to have a viva on Wednesday of the previous chapter. Solution.
Okay, sir. Thank you.
Okay. Are you done with this?
Yes, sir.
Yes, sir. Done.